we are predicting the sales. But this time we are going to predict the sales based on three different categories of ad spend: TV, radio, and 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 based on that we are going to predict the sales. And because there are three different methods, we are calling this as multiple linear regression. Obviously, our first job would be and see the first few things in the data so that we know that it has been imported correctly. Okay, so we can just go to generate with AI and say that read the data, and all that I need to do is to copy the path of the data and show the head. Hopefully, it will do its job. You can just say accept, in which case it will take the code. Otherwise, say accept and run. In this case, it will accept the code. It already generated the code. As you can see here, the code is written. It will, if I accept the code, it will not run it. But if we accept and run, it will also going to run it. So that accept run.
So your voice is breaking actually.
Let's see, because I'm using an external network. I'm not sure because of that. Okay. So anyway, I mean, we will be able to understand based on what activities we are doing. So this is the data that we have. We have TV, radio, newspaper, and we don't do any total ad spend because we want to this time to do it based on TV, radio, and newspaper spend rather than the ad spend. Okay. So what do you think will be the next step that we should do?
Filter.
Yes. So filter out the ad spend. We just say and save the data in a new data frame. Show the head of the new data frame. Okay. So seen it has done it. Yes. So this data, this new data frame is df underscore filter. So in subsequent prompts, it's better to mention that use the data frame df underscore filter because otherwise it may not know which data frame to use. Okay. Because you've just asked to filter the ad cells, and it doesn't know that which one it should use for any subsequent analysis. Before we get into the regression, we might want to do some exploratory data analysis, EDA. Exploratory data analysis is a descriptive analytics, which basically visualizes the data from different angles, and this may help in few activities before we actually proceed with the model building. So we'll talk about what those activities are and what is the utility of exploratory data analysis. But before that, can you tell me what type of exploratory data analysis you can, if this is data is given, what type of exploratory data analysis you can do with respect to building the model? Because exploratory data analysis can also be used for managerial decision making. That is a different category of exploratory data analysis, and This one is a different category, exploitative analysis. For example, if I want to find out or want to make a pie chart of total sales or proportion of total spend on TV or radio and newspaper, that will be more a managerial exploratory data analysis, because that helps the management to understand where we are spending the money most, or what is the total, what is the share of TV spend, TV ad spend compared to the total spend. However, this does not help us in any machine learning model building, because the model doesn't care how much you are spending in each of these categories. Management does care. So remember, when we are talking about exploitative data analysis in the context of data science, you first have to understand that what is the purpose of this EDA. And accordingly, you have to figure out that what are the different types of EDA you may want to do and it may be needed to be done. Because hardly will be a scenario where you will be told that do this particular type of charts. You have to discover or determine which charts you will make. Okay, not that you are asked that this is the chart and you make the chart. Making the chart is easy. Okay, prompt will make the chart. But knowing what to make given this data is the most important part. So can you tell me what are some of the charts that you would like to make given this data set? Very simple data set. What are the charts that I would like to make for exploitative data analysis for the purpose of building a model? Some
Time
of these we
series.
have done. Time series you cannot make, right? There is no reference to time here. Time series charts you can make only when there's a reference to time. There's no column which says there is time or date or time. So I cannot make a time series chart. And again, time series chart will be required only if you are doing a time series prediction. Right now, we are not doing time series prediction. We are only doing a regression. Okay, by the way, since you raised the question, what is the difference between a time series prediction and a regression prediction? So I could have predicted sales based on past sales data captured by different dates. That is also prediction. So I may have last, let's say, 5 years sales data, date by date. And based on that, I am predicting what will be the next month's sale. That would be a time series prediction. This is not what we're doing here. What we're doing here is that I have certain spends on certain advertising media. And based on that, I'm predicting time, predicting sales. I don't know at what time this spend has happened. Okay, there's no reference to that. What is the difference between, so this is regression. So what is the, whereas when we predict sales based on certain dates in the past, that will be time series. Both are predictions, but the model is very, very different. Can you fundamentally tell me what is the fundamental difference between a time series prediction and a regression prediction? Anybody?
Regression is having a relationship,
Okay. But time series also is having a relationship between
but it
the,
has got multiple variables.
okay.
Time series will be only with respect to time.
Very good. Okay, so first difference is, or fundamental difference is that time series prediction, there is only one variable, which is time. Okay, whereas regression, time is usually, time may or may not be, you can still have time as one of the attributes, but it is definitely the only attribute, and in many cases it is probably not the attribute. Like in this case, time is not an attribute. There are other features like the TV, radio, and newspaper advertisement spends. Okay. Can you tell me when you should use a time series prediction and when you should use these other kind of attributes? Assuming that you have both the time series data as well as this attribute data.
When we have some seasonal effects.
Then you should use time series?
Time series, yes.
Okay. Anything else? So you're saying if there is no seasonal effect, then I should not use time series. Okay. Anybody, any other views? Okay, it's like this. What is time series data? Time series data is that data where the time has absorbed the impact of all other attributes. You gave the example of seasonality. So what is the real attribute? The real attribute is the season. That is what is affecting your sales. But instead of using season as attribute, okay, like winter, summer, etc., as one of the columns. Instead of that, you are using the data captured over different dates, and you are ignoring for what season the sales was, because the assumption is that the sales on a particular date has already absorbed the impact of season. Time series is used when it is assumed that the impact of all other attributes can be season, can be, let's say, some sentiments like stock market, can be some impact, some events in the world economy, something can be to do with the change in prices, all other factors that are not related to date that has already got absorbed in the time. Is this concept clear? And that is why it is not that other factors are not affecting the outcome. It is just that time has absorbed the impact of all other factors. And hence, instead of considering 20, 30 different factors, if we just consider the time, that should give me the outcome. Correct? Is this clear? Yes or no?
Yes.
When will the time series analysis fail to predict? Or it is not the appropriate way to predict? When you do not use a time series analysis. Any thoughts? You will not use a time series analysis when the event that is considered as an attribute is a very rare event. Because time series assumes that time has absorbed all of these factors. When can it absorb all of these factors? When this is a regular event like season. Season is not a rare event, or change of season is not a rare event. Every year there is a winter, summer, etc. But every year there is no war. Every year there is no pandemic. So time series estimates fail when you have rare events. Such events are called black swan events. That is why, in spite of the fact that so many models have been built based on time series on predicting the stock price and stock market, etc., the real stock brokers, do not depend on the time series data. If that was the case, then the greatest data scientists of the world would have been the greatest stockbrokers. So they would have been able to predict the next day's price most accurately compared to any other stockbroker. That is not the case. Stockbrokers are not data scientists in most of the cases. And data scientists are not necessarily the best stockbrokers. Why is it so? Because most of the gains and losses in the stock market happens not because of events that has been regularly occurring in the past. What has been regularly occurring in the past is very predictable, and most of us will be playing in the stock market according to that. However, I'll not say good, but probably the professional stockbrokers, they don't work like that. They work on various other signals, sentiments of the market, some insider information, even to some extent, though that is not legal. Some rumor about maybe a war breaking out or a pandemic breaking out. Rumors. So these are factors which are not embedded in the time series because these have not happened before, or at least not happened regularly before. Now, the latest models of stock market prediction is trying to incorporate these external factors or this kind of uncertain factors into the model. For example, let's say trying to discover from the tweets or social media what kind of information is coming through, and based on that trying to predict the stock market. Okay, so it's a very, very important distinction between time series analysis and regression analysis. Is this clear? Any questions on this? Good. Great. So time series is out. We cannot do a time series chart on this. And by the way, we are not doing prediction yet. Okay, what I'm asking you to do is to do some exploratory data analysis, descriptive analysis on this data, not a prediction. Right now, I'm not asking you to do predict sales. That will come later when we do the regression. What kind of analysis of data based on this data you can do, which will be useful for prediction?
Scatter plot.
Okay, definitely one. Scatter plot of what against what?
Scatter plot as a sales against TV, radio, and newspaper.
Okay, we can do that, but that will not reveal us anything because anyway, that's what we want to do finally when we try to fit the regression model. That will be the output of our experiment. The purpose of EDA is to get some input, not the output. Output is when we plot the scatter plot, after that, the output will be to fit the line, best fit the line. That is the output. So scatter plot will not reveal me anything that will help me to build the model. Okay. The purpose of EDA is to get some inputs that will help me to build the model in terms of some data cleaning or some data pre-processing. It will reveal something about the data which needs to be probably reprocessed before it can be used to build a model. Scatter plot will not do that. Scatter plot is
Box
more like
plot.
an outcome.
Line chart.
Very good. Okay. Sorry, what was the other one?
Line chart.
Line chart of what against what?
Line chart between TV, radio, and newspaper.
No, you cannot have a line chart between TV, radio, and newspaper. Okay, line chart will work when one of the dimension is time. Okay. Line chart gives you a trend. You cannot use line chart in any other case. Okay, line chart, one dimension has to be time. The other dimension, the other one can be a measure, which can be a spend on TV or radio. Here we don't have the time dimension anyway. So we cannot have a line chart. Line chart works, remember, only when you should make a line chart only when the dimension we are considering is a time dimension, like a date or a time. Here, there's no question of a line chart. Okay, box plot definitely is one of the interesting charts that can be made. Why do you think box plot will be important from an EDA perspective?
Outliers, we need to find
Right,
out.
very good, very good. So box plot will help us to determine if there are any outliers. Okay. Why is it important to know whether there are outliers or not?
It will skew the whole.
It will skew the whole model. Okay.
Model.
And in this case, if there are outliers, what should you do with the outliers?
We need to give the treatment. Bring it down to the normal. Bring it to the.
What is the best treatment of an outlier?
Take the range or range or the median and then bring it down.
The best treatment of outlier is to remove the outlier. Because whatever you can do, whether you bring it within the range, use a median value or bring it to the whisker value, it is an approximation. It is not really what has happened. What has happened is there are two observations which are outliers, which we don't want to be affecting our model. So remember, any outlier, the best possible treatment and the easiest one, of course, because we don't have to really do anything, we have to just remove them, is to remove the outliers. The first option is never bring it to the normal range or replace it with the median. The first option is always to remove. When can you not remove and bring it to the median range or something like that? When it's not prudent to be removed and bring it to the median range, or whiskers.
The outlier parameter is very important, where we need to really consider as
Outlier is nothing to do with the parameter. Outlier is to do with the outcome. It's not the feature. It's not an outlier, is not a property of a feature. Outlier is okay. You are talking about this TV radio. Okay, so there are two different values which are outliers. Certain TV this thing okay, certain TV ads, some instances the TV ads were very high or very low. Okay, so in that case, what you're saying is that these are very important. So TV in general is important. Okay, but the specific value of TV is not necessarily important. You have to consider the outliers if the outcome against those outliers are significant. Means that when the TV value is an outlier, let's say on a particular month there is no TV advertisement, and during that month also we find the sales is high. Outcome against the outlier is a significant outcome, then only you have to consider the outliers, you cannot remove them. Okay, because there must be some reason because of which, in spite of not having a TV ad, still the sales is good. And we need to find that reason. It is to do with if that outlier has an outcome that is not normal. Okay. This is typically used in case of things that are in we'll see classifications where the one of the outcome is a very rare outcome. For example, let's say a disease. Out of 10 observations, only 5 observations have diseases, the particular disease. Others don't have. And the parameters against that, they are very rare, so they are outliers. So if I remove the outliers, then what is going to happen? The entire data set consisting of those instances where the disease was positive, the entire data set will go away. Or fraud detection. In those kind of scenario where the outlier results in output which is rare and which we want to measure, we want to predict the disease. We want to predict the fraud, which is by itself a rare phenomenon. There I cannot remove the outliers. In most of the other cases, the best treatment of an outlier is to remove the outlier. Is this concept clear? Yes or no?
Yes.
Great. So as a starting point, let us make the box plot. We have done the box plot in Math. We do the box plot here. So we'll say create box plots for TV, newspaper. Now, what is the 3 ones? TV, radio, and newspaper. Digital is not there. So TV, radio, and newspaper. Just to make sure it is not using the old data frame, use the data frame. VF underscore filtered. Okay. So see how easy it is. You would have to write so much of code. Okay, you had to know which is the libraries that you are going to use. Now you don't really care what is Matplotlib, what is Seaborn, as long as you're a business user and you know what is the purpose of a box plot. So you have to have that idea as a statistician or from the knowledge of that box plot plays an important role. As long as you do that, okay, you don't really care what all these libraries are saying. Okay, fine. So we have seen there is 2 outliers for newspaper. Okay. Ready? Yes or no?
Yes.
Okay. Okay, next step we did not do it in KNIME. In KNIME, if you have to do it, is slightly more complex. Let's say I want to remove the records where the records of those records which are outliers for newspaper. Okay. So remove, because we said that the best treatment of an outlier is to remove it. Remove the observations that are outliers. In fact, we don't need to specify outlier for newspaper because it understands the other two anyway don't have any outliers. Okay, if they have, then it will remove it. Observations that are outliers and save the data in a new data frame. So we'll say read or use the data frame df underscore filtered. Remove the observation that applies and save the data in the new data frame. Okay, plain English. Only thing that you require is the logic. You don't need to know a single line of code. 99% of cases, a very rare instance, you will get an error. If you get an error, there's also a concept of asking Gemini, explain the error and fix the error. Only if it is unable to fix the error, you have to go to an experienced developer. So think of how your organizational structure is going to look like. Previously, you might have 100 developers writing these codes manually. Now, all of these things will be done by the business users. Okay, who know the logic and who knows the objective of doing this. 1 out of 100 cases, you will be stuck in the code, which is a complex one, which even the generative AI is not able to resolve. Only in that one case, you have to go to a developer. And obviously, that developer will not be any 100 developer. That developer will be 1 or 2 developers who are very, very highly skilled. So you will no longer need a 100 developer team in your IT department. You will just require 1 or 2 very highly skilled people. That's how the future of IT is going to look like. Why future is already started happening. You was hearing reading the news everywhere that lower level, entry level developers are losing their jobs. Okay, so that's a reality that's going to happen. So let's see. Okay. So you're also saying the original data frame had 200 rows and 198 rows, and you can also see that this is correct. But if you look at the box plot has 2 observations which are outliers. The outliers have been removed. Original shape 204, shape after removing outliers 198.4. And you can see from the code that if if it was kind of you yourself have to do it, is not very easy to write these formulas and do that. Okay, great. What else can we do? Any other visualizations we can do? EDA we can do. Somebody is talking about correlation. No, you are talking about yeah, somebody is I think talking about correlation in TV and sales and like that. Okay, relationship. Is there a need to find a correlation between these attributes, TV, radio, and newspaper?
Yes, we will know which is the one which is yielding better results. Sales.
No, that you will know that is ultimately when you do the regression. Okay, and the impact, which feature has a higher impact on sales, that you will get to know by something called the p-value, which will come to that. But this is not about the impact of TV, radio, or newspaper on sales. We are talking about correlation between TV, radio, and newspaper. What does the correlation between TV and radio mean? If I say the correlation between TV and radio is high, what does it mean? It means
Interlink.
When the TV spend is high, the radio spend is also high. When the TV spend is low, radio spend is also low. That means
We can
TV
remove that.
and
We
radio.
can remove later on. We can remove.
Okay,
One
we'll
of
see that. Okay, we'll see that. So so first of all, you have to figure out if there's a correlation. If there's a correlation, if the correlation is very high, okay, either in the positive side or the negative side, what is the impact? Let's say TV and newspaper are highly correlated with each other. When there's a high spend on TV and high spend on newspaper, there's a high spend on newspaper. Radio spend is independent of TV and newspaper spend. Okay, what does it mean, or what impact it has on the model rather? Question is that let's assume that after we do a correlation, TV and newspaper are two features which are highly correlated, which means when the TV spend is high, the newspaper spend is also high. And the TV spend is low, newspaper spend is also low. On the other hand, the correlation of TV and newspaper on radio is very low. What impact it has on the building of the model? Why do we care about finding the correlation as far as the model is concerned? Anybody? Okay. Look at it like this. TV, radio, and newspaper are three attributes, three players which are affecting the sales. Now, if two attributes are highly correlated, it's like saying that two features are playing as one team. So they will dominate the impact on sales. So even if there is a significant change in the spend on radio, it will not get reflected in the sales if there is no significant change in the TV and newspaper spend, because TV and newspapers impact on sales collectively will be higher than the radio impact. That is why wherever there is a high correlation between features, you again need to treat it. Now, unlike the outlier case where we just removed it, here removing a particular feature is the last option, and usually it is not done. Why it is not done? Because there is something called a collective effort. That means if I have an effect on TV, an effect of radio, there is an effect of both TV and radio combined, which is independent of TV and radio. So it's possible that I've seen an ad on TV and seen the ad on newspaper, and the combined effect of seeing the ad on TV and newspaper together will push me to buy the product. However, if I had seen the ad only on TV or if I have seen the ad only on newspaper, I probably would not have purchased. It's a combinatorial effect. So if I remove any one of the features, the combinatorial effect will also go away. So in most of the cases, even though there is a very high correlation, you will never remove any of the features. There are other techniques to reduce the impact of it. One of the most popular technique is called principal component analysis. That means you combine these two features and create a new feature, new artificial feature. It's like saying you combine height and weight and create a new feature like basal BMI index or something like that. Combining two features and create a new feature that has the property of both the features, but it is no two separate features, it is one feature. That is one of the most popular methods, but it's slightly advanced, probably will not get into that. But so even though we may observe the correlation, probably in this exercise we'll not do anything with this because we should not drop any feature. If to do something, we should do something like principal component analysis. Is this concept clear? Yes or no?
Yeah.
Great. So let's do the best way to plot correlation is to show a heat map of correlation coefficients. Okay. So I will say use the data frame DF draw a correlation matrix among the three features: TV, radio, and newspaper. Okay. Just created this, you see that one is positive. I mean, one should have been blue and another one should have green. I could have given that prompt also. That make so. Is this kind of a matrix, correlation matrix, familiar to you? Yes, no? Is this matrix familiar to you?
Yeah.
Okay. So the diagonal shows the correlation with itself. So it is, it's all red one. Okay, because it's TV with TV, etc. And you can see the correlation between radio and newspaper is relatively high, not very high, 0.5, whereas the correlation between newspaper is relatively low. TV and radio is relatively low. Okay, so so I didn't anything on the correlation of the features with respect to correlation, because the correlation matrix shows that there is none of them are very highly correlated. We do not want to remove any feature. If at all, we'll do principal analysis, but that's something that of now, we're not engaging in. Okay. So, other visualizations that you think will be relevant for this area? I don't think anything else.
So your voice
But
is breaking.
this is more or less gives you a.
Voice is breaking.
Okay. Yeah, little bit internet problem is there, so just bear with it. Okay. 'Cause, I'm somewhere outside, so that's the only internet here. Okay. Uh, so
Maybe if you disable your camera.
disable your camera. Okay, yeah, that's a good idea. Do that. Yes. Yeah. Okay. Okay, so assuming that this is something, I mean, this is what is good enough for me, for us as of now. What would be the next step now that we are more or less ready with the data? What will be the next step that we should do? Should not be difficult. We have done this in the last class. Can I take the features as is, or do we do something with it?
We need to scale it.
We need to scale it, absolutely. Because we can see that certain data, the range is high, is different compared to some other data. So whenever you have numeric value for regression, we need to normalize it. Okay. And we're not calling it scaling because scaling involves at any range. Normalization can be from 0 to 1. Okay. So we'll normalize the features to not normalize the outcome, only normalize the features. Okay. So use data frame DF, no outlier. Normalize the values for TV, radio, and newspaper on a scale of 0 to 1 and store in a new data frame. Show the head, the new data frame. Okay. And run. You can see it is taking many libraries, sklearn, scikit-learn. But again, previously we had to remember that what libraries you should use for doing this. Now, gone are those days. You don't really care which libraries are used. Okay, so fine. You have scaled the data. Now the next steps are quite regular. What do you think is the next step? Okay. In fact, you can see here that we did not use this. So, previously the GenAI was not suggesting questions. Now it is even suggesting questions. Okay, so it was expecting that you tell what chart to make, it is going to make it. Now, even if you don't know which chart to make, you can ask to suggest charts. Okay. So what is the next step? Anybody? We are now ready to build the model, right? So what is the next step? Should not be too difficult.
Regression.
No, before doing the regression, what should you do?
Scatter plot.
Scatter plot is, we can do that, but scatter plot, let's do that. Okay, but that's not going to provide any input for our model. Okay, so let's do the scatter plot since. Okay. So use, but it's not going to be used. It's just going to give you some. The only thing that it may be used is whether a linear regression is sufficient, or you need to have a polynomial regression. Okay, so that's all that it can do. Otherwise, you don't need a scatter plot here, because scatter plot is what the outcome would be. Okay, so I can just say that make a scatter plot. Use, actually, if we wanted to make a scatter plot, we should have done it before normalization. So I should have done it here. Okay. So after this, because after normalization, scatter plot will not really be effective. So I should do it, okay, before normalization. So use data frame DF no outlier, because I should not use the normalized one, and draw a scatter plot. Draw scatter plots. Why scatter plots? Because for each of these features, to show the relation between TV and sales, radio and sales, and newspaper and sales. Draw the trend line also. Okay. So scatter plot is beautifully done. The trend line is beautifully done. Yes, as the only purpose of drawing the scatter plot here is to visualize if linear regression is good enough, or we should do polynomial regression. By the way, there is a small, I don't know whether you're able to see it. There is a very light yellow band around the scatter plot. What does it mean? There's a deep blue line, and then there is a small yellow band. Anybody? That small, not yellow, light blue band. That small light blue band is called the confidence interval. That means while scatter plot is showing that, while the line, deep blue line is showing the trend, you are 95% confident that the data will lie between the band of light blue. Okay, so that is what this light blue band indicates. It's a confidence interval. You again might have studied in statistics. Okay, so but this is this might be the best fit line for simple linear regression, considering each of these factors, but we don't know because we have not specifically told do a linear regression. Okay. So the next thing, so we have done the scatter plot. What is the next thing that you think we should do? Scatter plot is not the next thing that we should do after normalization.
Training and testing.
Right, absolutely. Now you have to split that, because now my data is ready. See, this is the logical steps and the pipeline that you must know. Okay, that's all that you need to know. Because as you can see, the code can be developed, but this logical pipeline, even now, for example, the generative AI is so advanced and is advancing so fast that if I just gave one line of prompt without doing anything, okay, just saying that this is the data set, please do a regression for this, or you not even regression, just say, oh, I want to predict sales based on TV and newspaper and radio spend. Even without specifying anything, today's generative AI is intelligent enough to do all of these things without any prompt. So while I mentioned that as business manager, you need to look at the steps, probably that even is not required in most of the cases today. Because generative AI will tell you the steps. It knows the steps in most of the cases. Okay. So, your input probably as a business manager boils down to, or human input boils down to, identifying the features that are likely to affect the outcome. Almost everything else most likely can be done very well by generative AI. Okay, we hardly have anything to do. Okay, so but as of now, let's assume that we have to divide it in training and testing. So let's take this. So we'll say that use data frame df normalize, df underscore normalized is z, split the data set into training and testing data set assess with 70% in training and 30% in testing. Use random sampling. Yeah, accept and run. Okay, seems to have done. So what it has done is that, so whenever it splits in Python, there is an X train, X is capital, and Y train, Y is small. So what it does is actually it creates 4 different data frames. Okay. X train consists of all the features in the training data set. Y train consists of all the corresponding outcome in the training data set. Similarly, X test consists of all in the training, and Y test all the features, and Y test the outcome. Okay. Why do we need to split the training into training and testing? We have discussed this, but I just want to make sure that you understood the concept. Why can't we just ask the model to get trained in the whole data set and then use that for prediction?
We can cross-check some of the data set for the.
Why
is
do you
it
need to do that? Why do you need to do that?
to test the model?
Why do you need
How
to test
accurate
the
how accurate is the model?
Why do you need to do that? Because why do we need to do that? The question is rising because whenever we are using the regression model, is already known that the regression model, the iteration will stop when the R square value is maximum. So it will start trying out with any blue line and it will iterate till it reaches a blue line where the sum of the squares of the error, root mean square error, is minimum. That is the line of best fit. That's the best possible line, prediction line that I can have. What is there to test about it? Because that's the logic that has been given, and it will arrive at that logic. Why do I need to test it again? That's the best fit line. Any thoughts? No? Okay. So let me ask you that I've briefly discussed about this. Do you remember this concept of bias versus variance trade-off? And I gave you an analogy on that. Anybody remembers that? Bias versus variance trade-off. Yes, no? No? Okay. So I think I mentioned this, but still I'll repeat that. Let's say there are two students. One student's method of preparation is something like this, that the student has got his or her hand on last 10 years question papers of an examination, of a competitive examination. And many students actually do that. And instead of focusing on the fundamentals, the first principles, the approach of the students, especially these days with the competitive examination, all the coaching institutes, that's how they do it. Okay, that's how they approach. So you take 10 years question paper or many question papers and many sample question papers based on the 10 years question papers, and the student practices and practices and practices the same pattern of questions, and he practices so much that cracking the exam becomes very easy. That's why you see that so many students from these coaching institutes which are training the student to crack an exam are doing so well. On the other hand, there's another student who, whatever, by design or lack of resources, does not have any question paper, but has built the fundamentals, the first principles very strongly. Student number B. My question to you is that if the question paper comes when these two students appear in the examination, situation 1, or maybe a competitive examination 1, the question paper comes which is very similar to the pattern of questions for the last 10 years. In fact, some questions are actually exactly repeat of previous year's questions. That many times happens. Which of these two students, A or B, is going to do better? Student A, who has practiced on question papers, or student B, who has focused on the first principles? Yes? Anybody?
Student A.
Student A. On the other hand, competitive examination 2, and sometimes competitive examinations do it like that to give the surprise. The syllabus is the same, but the pattern of question is entirely different. Certainly from objective type, multiple choice type, we have changed it to subjective, or the nature of questions have totally changed. Which student will do better now? B. So the first student who can do very well, or who does very well when the pattern of the question paper is same as last year's question paper, that student's method of preparation, method of learning is going to have, or is having, a high variance and low bias. I'm not getting into the mathematical calculation of it because it's more important. You are business managers, you are not statisticians. Okay, so it's more important for you to understand the conceptual part of it rather than the formula. You are not going to be a statistician. A statistician needs to know the formula. So there are formulas for this. There are formula to figure out the variance and trade bias, but I am not getting into the formula. So the variance simply means that as long as the future pattern is similar to the past pattern, a model that is having a high variance is going to perform very well. But moment there is a slight deviation in the pattern, such a model is going to do drastically bad. It is a reverse with the other case. The other case, it's looking at, in the other case, it has a low variance and high bias. So if the next competitive examination where the pattern has changed, student A is going to do extremely badly. Because moment the pattern of the question paper has changed, the student has no clue how to handle that because the student has not worked on the fundamentals. And the student will go around and saying that, no, this question paper was very tough. It was totally different from last year's. I mean, maybe they, some of them will be very frustrated, etc. But the other student who did not do very well will now do very well. Because the other student is based on fundamentals. This student is likely to have a low variance but high bias. Okay. Bias is the error that you get from the actual points, okay, the observed points compared to the trend line. So high bias but low variance, low bias and high variance. Okay. So similarly, when you're training a model, see, if I don't give any constraint to the model, not even saying that it has to be a linear regression, the model will find out a way by which the root mean square error is 0. What is that? Where the model will find out a line because it can iterate as many times as it wants. It will iterate first with linear, then we'll go to polynomial, different degrees of polynomial till it finds, because you have told the model that do not worry about the degree, you just have to make the root mean square error 0. So it will figure out a curve that will pass exactly through the points. The root mean square will be 0. And there will always be a degree of polynomial curve which can go through each of these points. Because it is dependent on computing power, so it will iterate and iterate till it finds that specific fit where the root mean square is 0. But the problem is that when it gets an unknown data, where the pattern is not very similar, it is going to give a completely wrong prediction. Okay. So such models are having a very high variance and very low bias. Error is very low, but the variance, moment things change a little bit, pattern changes a little bit, it is going to give you a huge error. Okay. We don't want that because we can't expect that the future pattern will be exactly the same as the past. On the other hand, if I ask the model to have a low variance, okay, high bias, it will be able to predict any uncertainty, but the error in the prediction will be relatively high. Okay. So even if it is the same pattern, it will give a reasonably high error. So neither of them is good. So we have to find a middle way. Okay, and mathematically it can be proved that what is the middle way. So you basically say a bias variance trade-off. Okay, that's where the middle point is. So that's why you never try to have a R square value equal to 1 or root mean square error equal to 0, because when R square equal to 1 or root mean square error equal to 0, your model has too much of variance. Just like you don't want the other way around also. A very low R square value or a very high root mean square error, that means the model has a very high bias. So you have to strike a midway. If you have a model which has a very high root means R square value and a very low root mean square error, the model is said to be overfitted. Is an overfitment, issue of overfitment. If it is the other way around, that means you have a high root mean square, low root mean square error, and a high R square value, that's overfitment. The other way, if it's a high root mean square error and a low R square value, it is underfitment. Okay, and you have to balance that. Is this part clear? This over variance and uh, mm, uh, variance and bias trade-off? Yes or no? Yes. Yes. No. Clear or no? Okay, great. So that is the reason when we say we need to test a model, what are we testing? We are testing whether we achieve the right bias variance trade-off. How we are testing that? There is no point in testing the fitness of the model for the data points that the model has seen. You give data points that are unknown. It is like the examination. You are not giving the same, you have trained the student has been trained in last 10 years question paper. Now, are you testing the student just picking up one of the question papers and giving to the student? No. You are making a new question paper. And this new question paper may be very, very similar to the 10 years or may not be, they may not have any similarity at all. If it is very, very similar, then the student A will do good, other will not good, and vice versa. But you have to test the student with a question paper that is not what the student has been trained on. And then you have to find out what is the score the student has achieved on that question paper. Similarly, here also you have to test the model on a new data set which the model has not seen or trained on. But the outcome of that data set is known to you, to the environment as a whole, but not to the model. And then the environment has to find out how much is the root mean square error or R square error. That will give the accuracy of the model. So that's why the accuracy of the model is always calculated on the test dataset, never on the training dataset. Clear? You can calculate on training dataset, but that is not of importance. The R square value on the training dataset is not of importance. R square value on the test dataset is what is important. Is this clear? Yes or no?
Yes.
All good?
Yes.
Great. So now let us do that. Rest of it is once the concept is clear, GenAI will do the rest of the stuff. Don't remember the code. Okay, so what we'll do is use the training data set, to train a regression model. We can give it together also, or we can give a single short prompt is also okay in this case. test the model on the test data set, show the R square, show the intercept and coefficient of the model. So that is the equation, and show the R square values both on the training and testing data set. Okay. Though for the performance of the model, we need the R square value on the test data set, not on the training data set. Okay. Okay. So you see that intercept is 4.6, coefficient is, this is TV, this is radio, and this is the newspaper. And you see the training data set, the R square value is 0.89, and the test data set, the R square value is 0.915. So we want a good R square value on the test data set. Okay. 0.9 is a fairly good value. We don't want to get a value of 1 because, so if we get a value of 1 on the training data set, that's very good. But we should never get a value of 1 in the training data set because that means the model is overfitted. Okay. Clear, everybody? So let us also say calculate the p-values of the features TV, radio, and speed. Okay. So this is the p-values. So does anybody remember that it has given many other statistical values? We can ignore that for the timing. So the p-value for the constant, which is basically intercept, TV, radio, and newspaper is this. So constant, the intercept, TV, and radio is 0, almost close to 0. Newspaper is 0.083. Okay, what does it mean? Anybody?
It can be ignored.
Okay, as I said, there is always a intersection effect, so it should not be
Greater than 0.05.
Yeah, I mean, no, it should not be ignored in the sense that I should not drop the newspaper as a feature. But what it says is that the null hypothesis. So what is the null hypothesis? Can anybody construct that? Because what I've seen many times is that while this is intuitively obvious, people are not able to construct the null hypothesis. Okay, because if the p-value is greater than 5%, it rejects the null hypothesis. Okay, null hypothesis is supposed to be rejected. But what is the null hypothesis? Can anybody construct the null hypothesis here?
Increase in newspaper spend will increase the sales.
No.
Increase in sales of TV and
conceptually you're
radio
correct.
and newspaper is same.
Conceptually, you are correct, but technically is incorrect. Null hypothesis always means that something is equal to something. Alternate hypothesis always means something is not equal to something. Okay, so you have to phrase the null hypothesis where something is equal to something. The increase of this will not qualify to be a null hypothesis, because null hypothesis cannot be written like that. Null hypothesis is written something is equal to something. And alternate hypothesis. So why it is important? Because alternate hypothesis never says that where something is greater than something. It just says that something is not equal to something. So what is this something equal to something, which will constitute a null hypothesis? Because it's very important to understand that. And we'll soon realize why.
TV, the influence of TV, radio, and newspaper are equal. That we can tell.
No.
Ad
no.
spend.
Ad
Ad
spend.
spend is
so-
equal to
no, no, no,
the sales.
So it is to be taken one by one. So it has to be so. For now, your null hypothesis is rejected in case of newspaper only, because newspaper the p-value is more than 5%. For other cases, null hypothesis is accepted.
So ad
Okay.
spend for newspaper is equal to the sales.
Ad spend, no. Null hypothesis is that ad spend. So for newspaper, ad spend sales with newspaper ad is equal to sales without newspaper ad. Something is equal to something. Sales with newspaper ad equal to sales without newspaper ad. For TV, sales with TV ad equal to sales without TV ad. Sales with radio ad equal to sales without radio ad. For case of TV and radio, the null hypothesis is rejected. Sales with TV ad is not equal to sales without TV ad. But for newspaper, null hypothesis accepted. Sales without newspaper ad is equal to sales with newspaper ad. First of all, tell me if this is clear, because this is very, very important. I have seen 99% of people fail to frame the null hypothesis. Intuitively, they are saying, like you said, that this is not important, newspaper ad is not important, etc. But the framing of the null hypothesis is very, very important, and we'll soon see why it is very important. Is this clear? What is the null hypothesis here? Yes or no? Yes.
If P is greater than 0.05, then accept
P
the
is-
null hypothesis. Correct.
If P is greater than 0.05, accept the null hypothesis. If P is less than 0.05, reject the null hypothesis. Right.
It's clear, sir.
Okay. Now, why it is important to understand this or frame this null hypothesis? Because when we are rejecting the null hypothesis, what are you saying? Sale with TV ad is equal to sale without TV ad. We are rejecting that. And sale, so we're saying the sale with TV ad is not equal to sale without TV ad. We are never saying, or this never concludes, the sale with TV ad will be greater than sale without TV ad. It's just saying that sale with TV ad is not equal to sale without TV ad. It doesn't say which one is greater and which one is lesser. That is why you cannot remove any feature from this. If you have to figure out whether something is greater, sale without TV ad, with TV ad is greater than sale without TV ad, you have to do a single side t-test, not two-sided t-test. So that's why it is very important to understand what is the meaning of this null hypothesis and what exactly is the null hypothesis. And by the way, this null hypothesis formulation is based on what is called frequentist approach in statistics. Many statisticians today discount the frequentist, or not discount, they say that frequentist approach should not be used in all the cases. It should be Bayesian approach. What is the difference? The difference is that in frequentist approach, you are considering, okay, let me give an analogy. Okay, and then you tell me in this case whether you should use a frequentist approach or you should use a Bayesian approach. So let me give you again, without getting into the formula and complex statistical theorem, I will just explain it with example. Okay, so that you can relate. That's what you need as a business manager. You don't need the formulas. Okay. So cricket matches, we all know. So India-Australia cricket match. Cricket, let's say there is a series of 4 tests. Okay. In one of the tests, India, let's say out of 4 tests, 3 tests India wins, will definitely favor India, and 1 test Australia wins. Okay, to make it simple, I'm considering all the tests are won in runs rather than wickets. Okay, just to make the comparison simple. So I'm okay. I'm not saying how many tests India has won, how many tests. There are 4 tests that has been played. Okay, in the first test, India scored 5 runs more than, and all the tests are decisive. So somebody won and somebody lost. Okay. In the first test, India lost by 5. India won by 5 runs. India made, and not the win. Okay, India made 5 runs more than Australia, and the test was decisive. That means at the end of the full 5 days game and all the rules of the game, India made 5 runs more than Australia. In the second test, India made 10 runs more than Australia. In the third test, India made 15 runs more than Australia. And in the fourth test, Australia made 100 runs more than India. How many tests India win and how many won, and how many tests Australia won? Yeah.
3 India won, 1 Australia lost.
3 India,
Australia won.
obviously, right? 3 India won. We all know that much of cricket, right? 3 India won and
1 Australia
1 Australia won. But if I add the cumulative results, the total number of runs of Australia was more than number of runs of India. Frequentist approach says Australia's won, because frequentist approach adds up all the cases and says that this is the total runs Australia has made, this is the total run India has made, and hence Australia has won. Bayesian approach takes each of these incidents separately. And for each of these incidents, who has won? Who has made more runs? The quantum of runs doesn't matter. Each incident is taken. In that incident, in this case, the incident is a test match, let's say. In that instant, who made more runs? By how many does not matter. Second incident, who made more runs? Like that, there are 4 incidents. Out of them, in 3 incidents, India made more runs than Australia. So India has won 3 cases, whereas Australia has won 1. The Bayesian approach follows the latter method. Okay. So there are certain situations where you will use a Bayesian approach rather than a frequentist approach. And there are certain cases where you use a frequentist approach rather than a Bayesian approach. Okay. So in this case, what do you think should be used? A frequentist approach or a Bayesian approach? In this case, the analogy is that is after spending television on ad, is the spend more? So here it is not null hypothesis like this is equal to this. Okay, this is the hypothesis 1. In Bayesian approach, there is no null hypothesis. There is a hypothesis 1 and there is hypothesis 2. Hypothesis 1 says television ad, sales with television ad is greater than sales without television ad. And hypothesis 2 says sales with television ad is less than sales without television ad. Okay. And it will consider individual periods. Let's say that period is a month. So every month I'll check, month one I'll check, sales with television ad is greater than sales without television ad, so whether that's true or not. If that's not true, then sales with television ad will be less than the sales without television ad. Then I'll do month two. Then I'll not see the quantum of sales by which. So it's possible that out of 6 months, in 3 months without television ad, the sales was only, with television ad, the sales was only 5% more. And the 5 out of 6 months. And the 6th month, the sales with television ad was 30% lower than the sales without television. For some reason, the ad went bad or something like that. That has a wrong message or something. So when you ran the television ad, the sale was 50% lower than the sale without that. And the remaining 5 months, whenever you ran the television ad, let's say 2 weeks you ran the ad and 2 weeks you did not run the ad. So the sales with television ad was 5% more than the sales without television. Bayesian hypothesis will say that television sales with television ad wins. That means you will have higher sales if you run a television ad. Frequentist approach will say that you will have lower sales without television. Okay, sorry, the other way around. I mean, in Bayesian approach, the month when there was no television ad, the sales was 50% higher. So the frequentist approach will say that you will sell more if there are no television ad. Is this concept clear? Yes or no?
Yes.
Or should I repeat? Okay. So now tell me in this case, which one you should use? Should you use a Bayesian approach or should you use a frequentist approach?
Bayesian.
Okay, depends, because let's say, I mean, in a real scenario, there's no reason why you should split it into buckets, unlike test matches, where you cannot ask the team to play on continuously for 100 days and find out how many runs each one has scored. So there is a period of the game. But here, is the period really important? May not be. So it is a very important business decision. So that's where the business person or statistician has to talk, because the statistician doesn't know. So if the business person says that, look, I want to ensure that every month I show a better sales, and there should not be any month I show a bad sales. By how much I show better is not important, but every month my sales should be higher than probably what it was previous. By how much higher doesn't matter. If that is the desired outcome, then I should go for Bayesian approach. Whereas if the idea is that I should find out the total sales, doesn't matter, the month bucket doesn't matter, then I should go for the frequentist approach. Okay. There are other better examples. This is not a very good example. There are other better examples. For example, the exit poll. The exit poll, many people are saying that the reason why exit polls are failing is because the exit poll follows a frequentist approach and not a Bayesian approach. In a frequentist approach, you are trying to find out by how many votes somebody will win. But the voting system in reality doesn't work like that. In voting system, somebody wins or loses. Even if somebody wins by 1 vote, it's a win. Somebody wins by 5 lakh vote is also a win. Doesn't matter by how many votes you win. Just like it doesn't matter by how many runs you win. It's still a win. So many statisticians are saying the reason for the recent wrong prediction in the exit poll is because exit poll follows, most of the exit poll at least follows the frequentist approach, not the Bayesian approach. Okay, so far fine, everybody?
Yes.
Great. So I think we have done a little bit of regression. We will get into the next one, regression, as we said, is it's a regression technique where you are trying to predict a continuous outcome like sales. But in some cases, you have to predict some categorical values, like whether a patient is diabetic or non-diabetic, whether a machine is going to fail or not fail, whether a customer is going to churn or not churn. Yes or no. These type of problems are called classification problems. Let us see how we kind of what are the algorithms that we have for classification. So we don't have much time today, but we'll just start off and probably next class we'll continue. Okay, just are you able to see my screen? Yes. Yeah.
Yes.
Yes. Okay. Great. So let us for the time being, just ignore the name decision tree. Okay. Let's assume that there are two factors, gender and age, on which the usage of app varies. And we have a data set which shows us which gender for different individuals, gender and age, which app they are using. Okay. So the first observation, for example, says that the first observation is a female, age is 15, and she is using, so this app is Pokemon Go. Then the next observation person is also a female and age is 25 using WhatsApp. Next one is a male, age is 32 using this app is, I think, Snapchat. Okay. Now, can I create a condition? Condition look like if else. Note that here I am not talking of an equation. I am talking of a condition. If gender is this and age is this, or age is between this or less than this or greater than this, then so and so app will be used. If gender is this, age is this, then so and so will be used. So eyeballing the data, can you build any of these conditions? Can we say, for example, if gender is male, what they should use, and if gender is female, what they should use? Yes or no?
No.
No, at least not with adequate confidence, because we know if gender is female, there are two females who are using WhatsApp and one is using Pokemon Go. And yeah, so yes, we can say with 67% confidence that or probability that they will use WhatsApp. But is that sufficient to say that any female will use WhatsApp? Probably not. Okay. Similarly, if I say male, we see that two males are using Pokemon Go and one male is using Snapchat. So again, there's 67%, with 67% confidence, I can say a male will use Pokemon Go, but may not be a sufficient probability. Okay. If I ask you to do the other way now we take age, but the problem with age is a continuous value. Right? Gender, we had only two conditions. If it's male, what will happen? If it's female, what will happen? Age, what will I say? If it's 15, what will happen? Is 25, what will, there can be something in between. Let's take a ballpark. I mean, let's take any random number. And let's say something like something like 20. If age is less than 20 and age is greater than 20, we just eyeball it. Can I say with adequate certainty what app a person will use if the age is less than 20 and if age is greater than 20?
Yes.
Okay. Both cases or one of these cases? If age is less than 20, greater than 20, both cases or one of the cases?
One of the cases.
One of the cases. That means if age is less than 20, then everybody is using Pokemon. But if age is greater than 20, I don't know. Because somebody is 25, uses WhatsApp, 40 uses WhatsApp, 32 uses Snapchat. Again, 6 or 7, 2/3, 1/3. But one part is sorted, that if age is less than 15, less than 20, definitely they'll use Pokemon Go. Now, since the other part is not sorted, on the other part, I apply the other feature, which is gender. So I now say that if age is greater than 20 and gender is female, age is greater than 20 and gender is male, can I say with confidence what app they're going to use?
Yes.
But if age is greater than 20 and its gender is female, the app will be WhatsApp. If the age is greater than 20 and the gender is male, the app will be Snapchat. What we built just now is a very simple decision tree. That's all a decision tree means. But obviously the complexity comes because the data set is not so small, where as humans, we can figure out which feature to be used to build the decision tree. We don't know whether we should make it less than 20, greater than 20, or less than 30, greater than 30. So that means we have to make, and there may be many other features, not just two features. So the concept is as simple as this. Why we need machine learning? We need machine learning only to do the iterations, because as humans will not, it will be extremely time consuming to do all the iterations and finally arrive at the right solution. The decision tree is nothing but this kind of if-else. It is not an equation. It is an if-else kind of statement, a tree of if-else statements, such that we can get to the most accurate prediction. Okay. I think we'll close here because the rest of the things will be pretty involved. We'll continue in the next class with the more complex terminologies and things about decision tree. Okay. Any questions before we close for today?
So the learning material, the slides, you'll upload
There's
into
nothing.
the.
Okay. Yeah. Slides, initial slides I've uploaded, and these slides I'll upload once I progress a little bit. Okay. And see, most importantly, you have to look at because theory is very little. Is all the the Python notebook and the 9 files that I'm uploading. Okay, so 9 files and Python notebook also I'll upload separately.
Okay.
Because that will be more important for you. Okay, then I'll see you then. I think I hope I mean I don't know that probably this hopefully this confusion will be cleared in next 1 week. So whatever is the final day, whether the class is 8:30 or the class is 1:30, whichever it is, we'll meet at that time. Okay. Okay.
Thank you, sir.
Okay. Thank you. Bye. Bye.